Hey everybody, welcome back. It's time for that next project. I'm Deez, this is my workshop. Today we're going to start another model engine build. These things are fun, they're addictive. Many of you warned me, and yes, you are correct. But more importantly for me, for Deez Workshop, these are plans, these are projects, these are reasons to use those machines. I like manual machining. I like to do it in a hobby fashion. I'm not a perfectionist, and I don't do finished carpentry, so to speak. I like to just make things that work and function. It's really cool and satisfying to be able to build something and then see it do what it's supposed to do when you're done. Now, today's project is going to be a beginner style project. If you're just getting into model machining or hobby machining or model engine making or any of that stuff, this might be a good project for you. The project we're going to do are these. Now, I've had this plan sitting around for a long time. When I first started contemplating working and trying to build a model engine, I just got a bunch of different plans. I looked at all the forums, and these were the kinds of things that were available, so I just downloaded a bunch. I printed a bunch out, and I decided I'm going to pick one and start with it. First engine I made was a finger engine. Second one was that Western Kentucky University, I think it's like a course that you take. It's out there on the internet, and anyway, it's a pretty simple horizontal wobbler style. That's the first actual air-powered engine I made, and it ran. It does a good job. It's over on the shelf. This is the Easy Engine Build. Letter E, the letter Z. Easy Engine Build. This is from the Home Model Engine Machinist Forum. If you look here, this is produced by that forum for beginners to start with who wants to get into model engine making and that sort of thing. It's a pretty basic engine. Now, what's different with this, it's not like one of the wobblers. I've done vertical wobblers, I've done twin vertical wobblers, I've done horizontal wobblers, I've done a bar stock wobbler. This one, two different types of cylinders, and it's not quite the same. There's a camshaft. So I thought for me, this would be a good next step to get away from wobblers and a different type of build, but still in a beginner style fashion. So this is what we're going to build. I'm also going to, if you read this page, I'm gonna supply these plans with a Google Drive link. I'll put that in the description of this video for anybody else that wants to build this. And I am accrediting the Home Model Engine Machinist Forum for producing these plans. That's really what's required. And if I can find a link to the actual forum itself and their download, I'm going to put that in the description as well. So I think this can be a fun build because it's a different type of engine that I've made. Everything else that I've made has been wobblers, so it's time to move on to something different. In this document, it tells you the materials, the procedures, the things you're going to need, the tooling you're going to need, the tool list, materials list. Now, there's a lot of pages in here. Thicknesses kind of gives you an idea of how to go about laying everything out. We know how to do all that. We've done that with the wobbler and everything. We've got the granite surface plate. We've got the bluing. So we will go through all of this. But they're telling you how to, create your different parts. There's a lot of pages in this printout. I think I have all the material I'm going to need. And they've got it painted up nicely to make it look good. All of mine are raw metal. I don't have anything polished up. But that's kind of what it's going to look like in the end. Also included the actual dimensions and everything, so we're going to utilize this as well. There's your crank pins, air holes, mounting holes. These aren't the best drawings and everything that I've come across, but we're going to use this to supplement the actual directions as we make this. I always like to start with a base because it's so easy. When you're starting an engine build or a project, the advice that I can give you is to just stop, take your time, read through it, get your head wrapped around it, maybe draw some parts out so that you know what you're doing, and maybe as you tackle each component, draw it out, put it on paper, and then you can take that piece of paper over to the mill or the lathe with you, and you can hit those marks that you're looking for. We are ready to start working on this engine. I've got all the materials I need. I'll do some adjustments as required throughout the project. I think most of you watching this channel and having a hobby shop of your own, you're going to be able to tackle this. I'm going to find out if I can. If I can do it, you can do it, that's for sure. We need a piece of 1/4 inch by 2 inch aluminum plate. I just so happen to have a piece of 1/4 inch by 2.5 inch plate. The base, I'm going to go ahead and leave it 2.5 inches wide. I'm going to leave both pieces 2.5. I'm going to change this to 2.5, and what that's going to do is that just means that I'm going to raise up all the dimensions that I'm making for all the other components. I just need to be careful that I need to measure from the top down for any holes or any of that sort of thing. We need 2 lengths of this, 4.5 inches long each. But that's how we're going to start. We're going to use this piece of bar stock. Let's get this cut into our lengths, get over to the mill, and start cleaning this piece up. Well, this blade is broke. Didn't think I would have to do that. Look at that. Let's try this again. Take 2. Well, we've got our 2 pieces made when we have some extra for our scrap pile. These are going to be the base and the vertical upright. Let's see, what does it say we need to do next? Both pieces are 4.5 inches long, pretty close. Layout location holes, use die, but large permanent marker works fine. Calipers, scribe lines, machinist square, scribe lines. Okay, we've got all that. Next, we want to center punch each of the hole locations, including the hole of the top edge for the bushing set screw and holes. So this just kind of tells you what to do in a picture, but I believe this is supposed to be supplementary to the drawing. So let's defer to the drawing. I've already been through this, and I believe the last page is what we're looking for. We have the base, which I'm going to actually write that on here. Alright, so we have our base and our frame. So these are 440s, really small taps for those, but that's okay, we can do that. I think the first thing we'll do, I always like to start with the easiest. Let's do the base. Since this is going to be the top, we're going to drill from here through, and we want to recess for the cap heads. Back to the mill we go. Alright, we're going to try this. We need to come over 1 inch and then over 3.5 inches. And we need to clear 106. We're going to use a 7/64, which mine is 107, 108. That should clear the screw. Then we will counter bore with an end mill big enough to accommodate the head of the 440 screw. I'm going to use, just for the plunge, I'm going to use a 3/16 end mill, and that's going to accommodate the head of the 440 screw that I have. And we need to come down 110 thou in order to clear everything. Okay. How did we do? Perfect. That is what we want. On to the next one. We need to come over 3.5 inches and do exactly the same thing. Base done. But I decided, in order to keep track of everything, I wanted to put some bluing on these parts that I have. And I use some dye chem because I know this is starting to already come off from the lubricants and the oils and the different things that I have. So this is the base, the bottom of the base. These are recessed. We have our 440 cap head screws. They fit in there really nicely. They're recessed all the way through. They do not sit. It's going to work out really well, and then we can determine what size we want in order to mount our top, our frame. The top, this is the frame. What do we want to do? Here's what they have. Looks like probably a bearing hole here, and then we have some through holes here. We're gonna have to go back to the directions and figure out what they're referring to. You know, I'm working from this side over, but they've got it upside down. They're gonna have, no, my bearing will be up here. I don't know why they got this upside down. We'll figure it out though. But I think that's gonna be a bearing. There'll be an air passage, is 1/8 of an inch. That's going to be probably that one. And then the other 4 are going to be tapped with 440. Well, today is the next day. We have our parts. We've got the die cam on what's going to be the frame. We already drilled the base, and this is not exactly 4.5 inches, so I need to be careful with where I put my parts. But I was thinking about this overnight, and something that I thought I would just go through the directions as written and just make them and trust that they're going to guide me through the whole thing. After reading a little closer, I need to go back and do like I always do and draw out every part, wrap my head around this project before I start cutting anything or drilling any hole. I recommend that you all do this as well, especially for the Elmer's engine builds. Those are one-sheet drawings. Many of these engines are one sheet, maybe 2 sheets of parts and dimensions. Sometimes there's just a small detail missing, and you need to do math and calculations in order to figure out the other side of a part, let's say a critical dimension, so you don't mess up a part. So what I'm going to do is go back through all these, and I'm going to draw them out on my wonderful grid paper, since I got some of that. I won't be drawing to scale necessarily, but I'm going to draw these out with all the dimensions that I need before I go any further, and make sure I'm not going to make any mistakes. Well, I'm not going to bore you with a time lapse of me doing all of this stuff. I think I'm going to go ahead and stop here. I've got, between just drawing this out, I got my head wrapped around it, and we're ready to make this frame. I just wanted to make sure there wasn't any gotchas. This is a pretty simple frame. We have a through hole. There's 4 holes that are going to be tapped for 440, and then we have a through hole of 1/8. And then we have a through hole of 3/8, 375. Pretty simple part. I do want to lay this out with the granite surface plate. I just like using this thing. It's kind of relaxing, and it helps keep me on track with what I'm doing. So let's go ahead, and this will be our workpiece. We're going to work from the left side over because I'm not 4.5 exactly, so I want to make sure we're working the same that I did with the base so that my holes line up. The critical piece will be the through holes for the base so that the top lines up. Height gauge zeroed in. That's good. First thing we're going to do is our holes here and the total thickness of this. We're going to go with 250. We're going to split the difference, and we want that to be 125. So we need to lower this down. We bring it up, and now we should be able to mark our piece. I always like to do just a little mark. I flip the part over, mark it again, and make sure that it's not out of whack, and that's pretty good there. So we'll go ahead and mark that. one side I do not have die chem, and that's because I'm not going to work from this side. So I need to come over an inch, which we're going to do this vertically. I need to come up an inch and then 3.5 inches. So let's unlock this. That's good enough, but that'll give me my 2 holes for the mounting. So we got that done. Now we're going to be working in this plane. All of my measurements are going to come from the top down. Our first hole is going to be the big hole. We want to come over 3125. So let's bring that back down. 3125. Up and over. Let's put a little mark there and check it. That's what we want. Well, as you can see, we got that laid out, and now we have our witness marks. They're very precise using the gauge, and this is going to keep me on track and oriented. This is another pretty straightforward, simple part. Really, we're just going to tap 4 holes for 440. We got a couple through holes to make, and that's about it. Well, I saved everybody the hassle here of just watching me center all this in, but we found the edge on this left side because we're going to work from the left to the right with all our measurements. We also found the edge on the top side. I've got my witness marks. That's going to keep me honest. I've got this moved over 312 thou and a half, and then down 375. We're going to spot drill it, and then we're going to drill it undersized, and we're going to ream it. I don't know that it needs to be that precise, but I'm going to go ahead and do it because I got the reamer and I can do that. I offset my parallel so that I don't drill into it, and these little holes up here will be in the way if I don't do that. I don't think it's going to rock. I've got this in there pretty tight. We're just going to go for it. That reamer is bent, or it's not in here correct. I think that reamer is bent. Can't use that. Yeah, this reamer is bent. I gotta mark it and put it away. I don't want to use this thing. It's bent for sure. That takes care of hole number 1. Let's move across and knock out these other holes. In the same plane, we need to just do 125 thou, an 1/8 inch through hole. And to double check the measurements, we are 35625, 35625 over, and we should be able to just drill that. No tapping on this one. Calls for a number 43 drill, which I have. 89 thou. Now we could also use a, oh, what is it, 3/32. If you don't have a number drill set, you could go up to 3/32 if you wanted to. I think this will be good though. And then we will tap it with my YG tap. This gives me the opportunity to use my new, let's see how well this works, my new little round tap handle that I made. I really should have a tap follower up here, but I don't have an inverted one. But a tap follower would help keep this stable because I'm moving it around. So far this is working pretty good. Well, I must say that worked really well. I recommend you make one of those. I'm not going to bore you with me drilling and tapping the rest of the 3 holes. When we get done, I might bring you back when I drill and tap the 2 bottom holes. We've got all the holes drilled on the flat portion. Now it's time to just do 2 more 440s. We're going to come over 1 inch and then 3.5 inches. Well, we got one done. We're going to come over 3.5 inches and we're going to do the other. I'll tell you what, I'm glad I made this not long ago in a different video. This thumb wheel, it's really easy to use, and when it bottoms out, it kind of spins on the shaft, so it's not actually over torquing, and you really get a lot of fine control. You feel what it's doing. I'm pretty happy with that. That worked out great, especially for this small 440 tap. Loosen that up. There's no damage to the tap. These YG taps are really nice, by the way. Happy with that. I went 3/4 inch, sorry, 750 thou depth. So I could use a 1/2 inch. I don't think 3/4, that'd probably be too long anyway. The reason I went deeper there is I wanted to see if I could get support. Before we try that, let's see if these 4 threaded holes are going to work. That's mounted in there really nice. Lots of support. My edge is lined up. And that was going to be kind of the tricky part. Everything else that goes on here, if anything, it's going to have a 1/2 inch more clearance, because this is, like I said, this is 2.5 inches instead of just 2. So we have a 1/2 more inch of height than the original plans called for. But that's going to be the start of our engine. We're going to keep this easy engine moving forward. We're going to work on the valve body and the cylinders next. We got the base and frame done. And I don't have 3/4 inch square stock. I have 3/4 by other dimensions. Regardless, I can make these out of steel, 12L14, or I can make them out of brass. I think since the pistons and that sort of thing is going to be made out of brass, I'm going to save the brass, because I'm going to have to cut quite a bit of this off. This is a 1-inch piece, but this piece of 12L14 is actually 873. What is that? 7/8. So this is 7/8, but I just need it. I need it to be 3/4. So what I'm going to do, I'm going to cut 3.5 inches. I'll actually cut more than that. I might go ahead and just cut 4. That's what we'll work on next. You know, I don't know how to math sometimes. That's not going to do it. I bet I need to take another 60 thou off. I think I need 120 thou off both widths. So I've taken 60 off, and if my calculations are correct, I need to take another 60 thou off. And since this is set up this way, I'll take it off of here. But let me measure this and just confirm that. But I'll bet I need to go down another 60 thou. $7.45, so I went a little too far. It'll work. Well, there's our stock to start with. I think the carbide on that face mill is starting to become a little worn out, but this should work. What did we end up with? All right, we have 746 on the other end, 749. If we twist it, it's a little bigger, 750. And I did that on purpose. What did we get? I turned it end for end. So we're 1 thou out. The next thing we need to do is cut our pieces. We need one that is 1626, and we need 1626 and 1875. So I'm going to cut this and leave that blue line, and then we'll go back to the mill and we'll start cleaning up these edges. Well, before we go any further, we need to find our final length. We've got one that's 1626 and one that's 1875. This might be a little hard to see, but I found this edge, subtract my 100th thou, that was the center. Then I did the math, 3/8 end mill, so that's 1865 to get to the center of that. And now I've got everything on the DRO. We're just going to take off the amount of material to get 1626, and then I'll repeat off camera the other part, and I just want to get these knocked out. Then we can start all of the machining and the holes and the through holes and all that stuff. Right now we're just making the blanks out of some stock. Been creating a huge mess, but sometimes that's what we got to do. Kind of a long day. I'll tell you, it takes a long time. You all know this. It takes a long time when you got to rough out your materials and you don't have quite the right stock. But that's what the workshop's all about. If you don't have it, you can make it. So we now have 3/4 inch stock, square stock, to be able to build the cylinder and the valve. We overshot each of those by about 4 thou. That's okay. The next thing we want to do is get down and actually drill the holes and the boring and all that stuff in the cylinder and the valve. We're going to keep this party rolling. We're going to work on the valve and the cylinder next. The valve we're going to start with, I deciphered as this sheet here. That is the part that is 1875 in length. First thing I want to do is drill and ream the large bore, and then we have to take it out and rotate it and do a few other options. There'll be an air inlet that will actually just protrude into the bore, and then there's 2 mounting holes. It's a pretty simple part, but I want to get this one knocked out before we move to the cylinder, which is a little more complex. They say to use a 7/32 drill. I actually have one that's a little closer to a reamer, 1/4 inch reamer, so we're going to drill it with that, which is, I believe it's 15/64. So we'll do 15/64. But before we do that, we need to center find the y-axis, and then we need to edge find the x-axis on the right side, and we need to come in a certain amount, and according to the drawing, 5/625 to the center of where that 1/4 inch hole will be. We've got our absolute set centered on the y-axis and on the edge here for the x-axis, and we need to come over, according to the drawing, the center of that hole will be over 5/625 from the edge. I'm glad I double checked. Always double check and reference and kind of make marks so that you know what you're doing. I needed to come over 5/625 from the other side. Now I could go ahead and drill this hole here because it doesn't matter, because I got to take this out anyway, and that's a square piece, so that is what I'm going to do. Get this reamed. I got that drilled through. I may have to use the, hopefully we got enough travel with this, is a 1/4 inch reamer. We're going to slow the speed down and run it through. Well, that went pretty well. Let's take that out of there, deburr the other side, and then we'll figure out what we're going to work on next. I don't know how well this will fit, but let's see. That is about as good as fit as you're going to get. There we go. So now I need to just focus a little bit and figure out where my next piece is going to go. If it mounts like, let's say this, which I think it will actually be like that, there'll be 2 mounting holes, and then there will be a hole that goes into the cylinder. And that's going to probably be on, well, it's the valve, sorry. It'll actually be a vertical hole that we will thread, and it'll be an air nipple that we can hook up to some air hose, and that way this will be the valve. I'm going to go ahead and study the plans before we do any more drilling, but that hole turned out very well. I'm happy with that. I decided to go ahead and put some die chem on these parts. Want to go ahead and put a few witness marks on these. I'm not going to, just to put some tick marks where roughly where I need to be, and then we'll use the DRO to finish these parts. So here's the valve. If you remember, we drilled our hole and reamed it. You got the inlet and then the air tube that will come through the frame through the back side of this. Let's go ahead and mark those where they're going to be. Let's start with the air inlet. That will be on this top face here. From the back side, 5625, and it'll be 875 across. Let's do 875 first. So that'll be the air inlet, and that'll just give us a visual reference. Tap and thread that so that I can put an air inlet brass piece in there. We'll figure out what tap we want to use for that. We've got our through hole air hole for the back. That's going to be screwed to the back of this, something like this. And then we have our 2 mounting holes marked. So that's going to give us good witness marks. While we're doing this, let's look at the cylinder. We might as well go ahead and mark this as well while we're doing that. Let's go back to the valve. I think I just want to do the mounting holes first, and then we will recess those. We already did the math on that. Yeah, already got that. We need to come down 110 thou to clear the head of the screw. So we'll recess that with a 3/16 end mill, and we're going to drill that with 106 7/64. That's what we need. Let's put this over in the mill and get the 2 mounting holes done first. Well, I saved you the hassle of watching this. We need to come in 125, 125 for this corner, and 125 from that edge over, and 875 from the end for that one. These will be through holes for the mounting brackets. There's the mounting holes. We'll get this set up and we'll finish drilling all these holes, and I'll bring you back. I'm going to do the rest off camera. It's just more drilling and tapping. It's just boring stuff, right? So let me get this piece cleaned up. I'm not going to record it because it's just slowing everything down. You've seen enough. I'm going to jump around a little bit. This is the cylinder. We need to do a 1/2 inch hole, 1.375 deep, 1 inch, 375 thou deep. Won't go all the way through. We did get the valve done, but we need to make the air inlet, and I went ahead and threaded and tapped that for 1032. I'll show you that when we get done with this, and then we'll make the other part. But we'll go to the workbench once I have all these parts together, and we're kind of resembling sort of an engine. But we need to come down 13750, 1 inch, 375 thou. Well, we got our depth. Now we need to ream that. This is our last hole. We're going to drill into the chamber. Hopefully we got everything lined up. This is going to be 1/8 drill. we did it right, we've got the valve, the cylinder, and the valve done, and now we just need to make our air inlet, and then we'll go do a mock assembly and see what this thing looks like. Once again, like every project, we've made a giant mess. But that's okay, that's part of it. I believe we have some parts done. It's time to do a test assembly. This is the valve, but we have our cylinder done, It's got the bore that's reamed, our 2 mounting screws, and then the air intake for the piston. We have our valve, 2 mounting holes, the through hole, the air intake, and the exhaust back here. I went ahead and made an air inlet for the valve, thinking, knowing we're going to need that anyway. That's going to go up here. I have to shorten that a little bit. That's fine. We will. I believe that the valve will go over here, and we're going to use 1032 screws. We just got to right size this. Those won't be long enough. These will work. It's a little different of an engine, a little different than I've made before. But if it lines up, this should screw in there okay. And then this one hopefully will line up with the other screw hole. Looks like it's going to. And then this would go, yeah, like that. And hopefully we got that right. It looks like these are going to fit. Yeah. And if you look at the picture here, you've got the big piston on this side that will go to the crank disc, and then the flywheel will go to the smaller valve rod there. This has been a lot of work, but I'm trying to cram as much in as I can before we close these out. Overall, it's coming together. Well, we're going to bring this part 1 to a close of the easy engine build. Again, this is from the Home Model Engine Machinist forum. They're the ones that collaborated and made these plans. We're just going to go with it and see if I can make the thing chooch and do what it's supposed to do. We've done quite a bit in this video. We made the base, the frame, we made the valve, we made the cylinder, we even made the air intake to go with that. There's a lot more to do, but this is a very good start to this engine build. There's been a lot of progress made on this. We're going to pause here. We're going to close part 1. So I hope you enjoyed part 1 of this model engine build. If you haven't subscribed, please do. It really helps out the channel. Memberships are now open. No pressure whatsoever, but if you're interested in supporting the channel, that is an avenue that you can do to help me with supplies and things like that. You don't have to. I just appreciate you all watching, but that is an avenue if some of you are interested in helping out the channel. If you want to send me a sticker, we'll stick it on the sticker board. With that, I hope you enjoyed the video, and I hope to see you on the next one. Thanks for watching, everybody.